afternoon, everyone. So I'm sure some of you probably know me already. If not, my name is Sriram Aaleti. I'm an associate professor in civil engineering department, mostly with the emphasis on structural engineering. Our studio is about process of prefabrication. We started the studio a few years back in spring 2020. That's exactly when the COVID started, right? So we kind of feel like our studio is a COVID studio to start with, and then we're trying to make some progress. And then the last 2 years or so, we have a little bit more consistency of doing things regularly, and then try to navigate the precast pre-stress related information through multiple classes. So our goal of our overall goal of our studio was trying to integrate both construction engineering, structural engineering together. And also we wanted to expose our students beginning from sophomore year all the way to senior year continuously to a precast pre-stress related topics. So the way we chose different classes where we integrate is based on the, every year, and the students go from the sophomore to the junior level. They'll be seeing some aspects of precast in that classes, and when they go to the senior level classes, they will see some aspects of those classes, and when they go to graduate level classes, they will see aspects of some of the pre-stress too. So that way they can combine everything from what they learn or what they have seen from their sophomore year to the graduate school, and then can get a little bit bigger picture of entire precast industry. We partner with two precast companies in our state, Forterra, which is focused on bridge construction, and the Gate Precast related to buildings. We also work with PTAC 3D, a detailing company which develops software for detailing precast structures, so that the students can learn about some of their software during some of the classes, so that they can use it in their professional careers. So there are the different things that we do as part of the studio, as majority of you probably also doing something very similar. So I'm not going to read through, but I would like to highlight that we definitely do precast plant tours, and then get the students to PCA conferences. We do have guest lectures and presentations from several people from in the precast industry, whether it be material suppliers or the precast producers, or our regional director who comes in and talks about the precast design, and then what is the implementation, some construction related issues. We do pretty regularly compete with the PCA Big Beam competition. And then we use some of the software tools in some of our senior design classes to explore, at least expose our students what's out there, and that way they're at least aware of it. So I'll briefly talk about the sophomore engineering class, which talks about construction materials. We take this an opportunity to get the students excited about concrete. So just Alabama, in the state of Alabama, we are kind of split between multiple building materials. So we have highest, I think, the 3 or 4 concrete cement producing plants in the state of Alabama. So they push us to focus on concrete. But we also have 4 steel mills in the state. So they always tell my department chair that we should focus on steel structures. And then the down southeast is big for wood. So we do have a lumber mill right across our university. So that some of the owners of the lumber mill, they want us to focus on wood design. So we kind of try to walk a thin line, not to upset all the 3 people. So we kind of trying to get everyone exposed to all building materials as much as possible. But given the 262 class, where we wanted to get them a little bit more exciting, and kind of get towards concrete a little bit more, I think biased towards concrete, because me and my other colleagues are interested in concrete. So we try to get the students excited about concrete by doing hands-on stuff. As you can see, as part of this project, what we have been doing for the last 3 years is related to tornado shelters, and how can we use precast construction, as well as how do you do the material design. Then think about what are the different aspects of design aspects one should consider. Again, these students are just sophomore students, so they really don't know the design process. So our intent is mostly geared towards understanding the materials, and then the casting side of it, and then tie it back to what precast industry typically has. So we were looking at mostly precast panels, and the students get to design panels, and then we have an amazing facility where we can shoot 2x4s at 150 miles per hour, and we can shoot four projectors at the same time. So we get the students to design something and test it, and based on the results they see, they can go back and tweak their designs. Either they can fix their concrete mixes, or they can add additional steel fibers, or regular polypropylene fibers, and they can cast the second panel, and then that's their final project. So this is just a part of their entire class, but then that definitely gets them excited about hands-on construction, as well as the see some of the the concrete pieces blow out, right, during an impact. So I'm going to show you a quick video of the testing. Can you guys see it? This is done by my colleague Armin, who runs that class and is a part of the studio. So you guys can see what type of configuration students use, right? So, so just to not to drag the video. So the intent was to just to get the students to see multiple failures, and then they can actually see the what happened. So what they learn out of that exercise was, when they have a really poor concrete, like if they have a very dry mix, they couldn't compact it, then it failed, and they're able to see a different reinforcement arrangement, how that's going to help, or how the failure modes are a little different. Most of the panels actually failed, and the way we grade the students was to they need to use the minimum materials, and there is a and it's supposed to we also measure how much mass is lost. In other words, how many pieces broke into, and then if it is disintegrated into dust, then we couldn't. But most of the times it breaks into 10, 20 pieces. So we were trying to get them to understand about the distribution of reinforcement, right? And also it's not about the more quantity, it's about putting it in the right location and the right distribution. And that definitely helps them to think about what are the things it's critical for design. And then we are just getting them to prime about, or at least have experience about how structures fail, so that when they come to the next junior and senior level classes, they can take some of these experience to design better structures. So when the other class we also deal with, we also use to expose our students to precast is the introduction to construction engineering class. Typically, we have around 70 to 90 students every semester. So in this class, we try to get the aspects of construction and costing, how much it costs, and the typical scheduling process, and how that is different in terms of precast industry or traditional cast in place construction. That's something we are trying to get the students to have understandings. And typically we have Dan Aikenroad, our regional director, who comes in every semester to give a presentation to just give briefly about Precast 101 and also talk about some of the aspects related to the cost estimation and also project management side of it. We take this as a good segue for them to think about not only just the design side of it, but then the marketing and then the business side of it too. So and there have been a lot of interest from our students about some of the presentations from Dan. Then the next one we did last year was a pre-stressed concrete design class. We did do several plant tours, one to Gate Precast and the second one to the Forterra, the bridge precaster. And we also participated in the PCI Big Beam competition last year. As you can see here, the students designed and with the help of the Gate Precast, we constructed the big beams at their plant. The students were the one who actually poured the concrete in the farms, and it was good. It was very interesting to see for them to learn about how to handle the pouring concrete. Um, in the bottom down picture, you see we were testing the BCA Big Beam competition, tested the lab, and last year we actually won the national level first prize, and the second team also came out to be a third prize. So that was a pretty good experience for the students, and we plan to continue that participating in PCA Big Beam and have collaborations with the Gate Precast. And some of the other aspects I did not put into the PowerPoint slides here, but the studio had helped us to expose our program and our students to precast industry, at the same time also help the precast guys to know about what we are doing at our university. So that actually led to some grant proposals to develop next generation reduced carbon dioxide for concrete construction. We recently got a big NSF project, close to $750,000, where we are looking at reducing carbon dioxide usage in concrete construction. And the precast industry is a part of the team. So Dan is involved with our university to provide some insights into plant, what is the standard practice at plant, and then some of the technologies we are developing, how that could be used towards the precast industry. Then with the with the bridge guys in Forterra in Birmingham, we also recently got a small grant from Alabama Economic Development, which to help us to develop a UHPC very specific to local materials, as well as you can be used by our local precast industry. So that definitely Precast Studio helped us to share both of our experiences and also learn about what each of everyone's capabilities, and then hopefully get the better out for both the university as well as to the students and to the precast industry. That's pretty much for me, and I'm happy to answer any questions.
Where did you get the additional funding for local materials?
So the Alabama Economic Development, there is a program for Alabama companies to explore the business opportunities or improve the lives of Alabamians, I guess. So I was able to work with our local producer, and I put the proposal, but it has to be working with industry together. So I put the proposal together to develop a UHPC mix for them. The big NSF grant we got, it's about accelerator. It's called a track H accelerator. So that's they have two phases. We were one of 15 universities, 15 teams in the entire country. We got the phase one. I'm not the lead. I'm the senior personnel, but the lead we were looking at how do you incorporate CO2 into concrete mixes. So they're developing new technologies geared towards incorporating CO2. I'm the liaison between the research team and the precast industry, and I'm working with Dan to see when we are developing these technologies, can we curtail our technologies more focused towards precast industry. And then the Dan is going to be serving as on the advisory team to provide input and then provide the guidance to that material research team, so that we can try to take this the research methodologies into practice. So there is a phase two proposal will be due sometime in October for a $5 million. Um, then we are going to go after that so that we can work with our local precast producers to see if we can implement some of those CO2 measures to improve or to try to accommodate CO2 into the construction.